Alright, so today we're going to actually kind of do what we've been doing, just in reverse order. So now we're going to be looking at a graph, and from the graph we're going to write an equation from it. There are a couple test questions like this, so it's worth knowing how to do. It can be a little bit tricky, but as long as you just take your time, and follow in a logical order, it's not that bad. So first, let's kind of get an idea here. Let's trace some possible sine and cosine graphs out of this drawing, because once again, every graph you'll be able to write a sine or a cosine for it. And so on the test, you're going to be given a picture of a graph like this, and you're going to be asked to write one equation for a sine graph, one equation for a cosine. So let's start with sine. So sine normally starts, let's see, on the y-axis it normally starts here. And so you see here, like this graph actually passes through that point. So we could trace a sine graph like this. One thing to keep in mind here, though, is since it's going down to start, that means that it is a negative graph. Now, cosine normally starts at the maximum, so we have to find the closest maximum point here. And then if you were to trace the cosine graph, it would go like that. So one thing to keep in mind is that this is going to have a negative phase shift, because the point normally starts here. It's been shifted back. And I know it's kind of hard to see, but that's a negative pi over 4. So what we're doing here, take a second, pause the video, write this down. Basically, we're going to draw on what I'll call our fake x-axis. Basically, we're finding the midline of the graph, figuring out whether we want to find a sine or cosine first, and then we want to find amplitude, vertical shift period, and phase shift. Now, the nice thing is these sine and cosine graphs will share those three values. The one that's different is the phase shift, because remember, a sine or a cosine, they're shifted versions of each other. So that's why you have to figure out whether you're doing sine or cosine first. And then lastly, you plug it into the equation you already have, and you simplify. That's it. So let's look at this guy. We want to find a sine and a cosine. So first thing let's do, I want to draw in my midline, which is right there, because that's going to be used to find my vertical shift, because that's the vertical shift. Alright, now to find the period is easiest, I think, to find, just going maximum to maximum. So that distance would be the period of our graph, and then the amplitude is from the midline to the top or the bottom, so we'll call that amplitude. So those are the three values that are shared for both equations, so we might as well go ahead and let's find those first. So the amplitude, let's see, 1, 2, we went up 3. So the amplitude equals, oops, why did I do it that way? Amplitude will equal 3. The period of the graph, so it's going 1, 2, 3, so it's 4 marks. Each mark here is pi over 4, so it's 1 pi. Okay, and lastly, the vertical shift is the shared value. Vertical shift is just up 1, so it's 1. So those are the three values that are shared for both graphs. Now let's see, let's find the sine first. And I say sine first because if I'm starting at an intercept and then going around, this graph, it doesn't have a vertical shift, or sorry, it doesn't have a phase shift, because the intercept of our fake axis here is on the y-axis, so there's no no phase shift. So phase shift equals 0. So we're just going to plug her in. So y will equal the vertical shift, which is 1. It is a positive sine graph, plus 3 sine. Let's see. We gotta find b still. Ooh, so how do you find b? Well, we have to set that equal to 2 pi over b, remember, because that's the period of the graph. So if you were to cross multiply, b times pi equals 2 pi, so therefore b would end up equaling So you cancel out the pi's. B equals 2. So we have a 2. X minus 0. So then our equation is y equals 1 plus 3 sine of 2x. Okay. On the cosine. So cosine normally starts at a maximum. So a cosine graph would normally start here and go like that. So what we have to do is we have to find that distance that it went back, because that's the phase shift. In this case, it went a negative, let's see, if it starts here normally, and it's 1, 2, 3 back, so negative 3 pi over 4. So we plug that into our equation. Y equals 1 plus 3 cosine. I know that doesn't look nice, but you get the idea. 3 cosine. Nice thing is the b value is still the same, so we're still using 2. And then x minus a negative, so it's plus 3 pi over 4, which will simplify and equal, oops, what did I just do? I just zoomed in. I did not want to zoom in. Oh crud. Give me a second. I messed that up. There we go. Oopsies. Always fun. That's like silly technology and its craziness. There we go. Okay. Oh boy. In either case, let's finish this. I'll mess with it later. Right, so then simplify 1 plus 3 cosine. Distribute the 2. 2x plus 3 pi over 2. And that's your answer. So what you're basically doing, identifying all the parts and pieces, finding the phase shifts for each individual graph, and then plugging the values in and simplifying. Alright, so let's look at the next one. So I'm running out of time here. Go ahead and take a second, write that down, give it a shot. And also take a second, pause, write that one down, give it a shot. See how it goes. Like I said, we'll have more time in class to practice. But hopefully that makes sense. And I will see you guys later.